Dos, tres.
Hello, everyone. We are going to present the article called A Didactic Experiment to Evaluate the Calibration of Pressure Gauges in Low Medium Vacuum Range. We are in the 5th semester of Renewable Energy Engineering. My team is composed by me, your presenter, Jessica Beatriz Sinal Molina, and my other team, Marco Adaya Olan, Eldi Jacqueline Rivasoy, and Jimena del Rosario Cardelón Morales, and David Misael Vázquez González. What we are going to talk in these presentations? Well, the contents are number one, what's the experiment about? We are going to explain most what the experiment talks about, and 2, introduction, 3, methodology, 4, results, and 5, conclusions. Number 1, what's the experiment about? Well, in these occasions, talks about an educational experiments and physics institute of the university called Sao Paulo, with the main purpose of evaluating the difference in measurements by 4 different types of manometers. We have the pyramid, thermocouple, and 2 thermistors compared to MacLeo reference manometer. And we can see this imagine. It's about pyramid, manometer, and they have these characteristics. And yeah, that's one example. And the pressure rank, it's from 10 to the 0 pascals to 10 to 1 pascals. The result of the experiment showed that all the pressure gauges evaluated to get different readings. This highlights the importance of calibrating the gauges to get a accurate understanding of the results they improve. In fact, and in summary, we can tell that the study showed that pressure gauges can give different measure of they are not properly calibrated, which can this affect very the results, and especially in vacuum experiments.
Introduction. Highly developed industries such as micro and nanotechnology, aerospace, petrochemicals, and pharmaceuticals rely heavily on accurate pressure measurements. Also, medical applications such as blood pressure measurement require precise measurements for accurate diagnosis. In the pressure range from 10 to the negative 1 Pascal to 10 to the 3 Pascal. Important applications stand out, such as drying, distillation, electron E-beam welding, steel production, and blood pressure measuring. To measure pressure in vacuum chambers, several sensors and devices designed for low and medium vacuum are used, such as McLeod, pinning, Pirani, Bayer Alpert, thermocouples, thermistors, boredom pressure, and among others. For example, a Pirani manometer measures pressure by bearing of resistance of a head filament in a warehouse bridge. For example, that right have a blood pressure manometer. It's used in a hospital for the doctors, and is your essential instrument.
Well, we are going to talk about the methodology explained in the article. In this case, consists of a vacuum chamber connected to Edwards number 8 mechanical rotary pump, we can see and imagine what we are talking about. And then the rotary Beko diffusion pump for pressure gauges in the dress are connected independently to the vacuum. What does this means? This means that they are separate of the vacuum chamber. Is the thermocouple Rochester CBC GT 100 range from 0 minus 1.333 H Pascals. We are going to talk about the Pirani CVC GP 210 range from 0 to 30 pascals. The third one are the Pirani Edwards Pre 10K, range from 0.001 to 5 H pascals, and 2 for 15 thermistors GT 314H, range for 0 minus 6.6 H pascal. Moreover, a liquid nitrogen trap was set between the systems and legible mercury. The MacLeod gauge range from 0.0001 to 1 H pascals used to standard pressures. A needle valve is used to vary the pressure inside the systems. An overview of the setup is given in a figure. We can see it's used as for reference since it's considered a standard in pressure measures. We have another ones like I don't know, calibration parameters. It's used in laboratory and to take temperature and humidity. These are very explications too technical, but yeah, it's in resume it's all. The next one.
The results of tested gauges in comparison to a reference, a muffled mercury gauge, are given in table. In this table, as well as the explaining uncertainties for a confidence level of 95%. The result regards three discrete measurements, considering the variance and the resolution of the test gauges to compute the expander uncertainty. Can you see how it's up the pascals? The measurement of thermocouple, Pirani, the thermistor can be up conform with a pressure it's so elevated. It's possible to be observed difference among the gauges, especially for greater pressures inside the vacuum chamber, especially for volumes higher than 20 pascals. Based on the table one, it's the first, and figure 3, that is it possible the observed difference among the gauges, regardless of the expand uncertainty? One explanation for different regards on the physical working principle of the tested gauges, while both thermistor and Pirani gauges are based on balance of resistance in a Weston bright. The thermocouple is based on the potential difference in the thermocouple connection. Although the difference, the comparison to a standard allows the user proper correct them. A second degree polynomial curve was also plotted as a calibration curve, representing the pressure as a function that a second degree polynomial curve is adequate a calibration curve for the test gauges in the range from 0 to 200 pascals. From the detective perspective, it is possible to visualize the behavior of each pressure gauge as a function to standard McLeod gauge results. Those systematic deviations shall be connected in order to use yielded results.
We are going to talk about author conclusions. Well, the article of the experiments allow underground students to visualize how different pressure gauges with its different physical principles perform in comparisons to a standard device. And deviations were observed in these presentations in the gauges tested, suggesting that they may need two corrections to avoid systematic deviations in measures. In summary, we can tell that the author concludes that the experiments provided the deeper understanding of how different pressure gauges work and how factors such as repeatability of resolutions can affect these measures' accuracy.
The conclusion of for all the team uh, next to can read and and evaluate the article. The conclusion of the analysis of this document, we have been to able. Uh, I can conclude that there is a tool for each type of need. In this case, pressure gauge since in the matter of pressures, it is necessary to use to appropriate a pressure gauge depending on what you are looking for. Since they are a very delicate issue in which measurement error or a small failure to have to the results can have from a slight negative change more. Uh, you have a serious consequence because the gas it I have a properties to its so specific gauge because mm, in the ductal ventilations uh, we need a specific gauge because the ventilation can broke and maybe should uh, uh, mm, uncertainly measures and you can fail with your proposal and can you say that it's all the presentation. Thank you for your attention and Jessica,
Uh,
you need to say the date, please.
I think that that's all, isn't it? I think that it's important to mention that one meditions and you can give wrong results, and that's the importation of the calibration of these vacuum systems. I think that's all, and thank you for watching.